A Telebyte video.
Welcome to a demonstration of IEEE's 802.3 CG 10BASE-T1L compliance testing using 1.0 volts peak-to-peak and test mode 2. This demonstration will feature Analog Devices Evaluation Board and Ethernet PHY evaluation software with Telebyte's digital analyzer, probe, and software. The equipment and software in this demonstration will allow you to identify problems, analyze transmit output voltage droop, perform repeatable testing, see clear pass-fail results, and produce printed reports with graphs. The equipment and software in this demonstration includes Analog Devices eval ADIN 1110 EBZ EVM evaluation board, Analog Devices Ethernet PHY evaluation software, Telebyte's 4975 digital analyzer and software, as well as Telebyte's 4975 P01 probe for signal capture. This setup can test with 1.0 volts peak-to-peak and 2.4 volts peak-to-peak. It can also test with test modes 1, 2, or 3. Let's take a look at the devices and software we'll be working with today. In the bottom left-hand corner, we have our Analog Devices Evaluation Board. This board receives its control and power via a USB connection that goes to the Telebyte 4975 digital analyzer, which is loaded with Telebyte's 500 software, as well as Analog Devices Ethernet PHY evaluation software. The evaluation board is also connected to the Telebyte 4975 P01 probe via an adapter cable from a 3-terminal SPE screw connector to an RJ45 connector. The probe also has a 100 ohm termination on the front, and from the back it is connected to the digital capture card that is installed in the digital analyzer. In order to enable USB power on the ADI evaluation board, do the following. At P5, connect a USB cable. At P4, jumper pins 3 and 4. Next, we need to connect the probe to the 4975 digitizer card. This is done by using an SMA to SMB cable, which is connected to the digitizer card and also to the back of the 4975 P01 probe. Then we need to set the attenuation to 0 dB. This is accomplished by manually sliding the red switch on the probe to 0 dB. Let's take a look at the software in action.
We are testing using the Telebyte 500 series software, a signal analysis software with an Analog Devices ADIN 1110 evaluation board. And we're using a termite program to connect to the serial USB connection to the eval-ADIN 1110 EBZ evaluation board. So you can see I can send command to the Analog Devices board through the serial interface. Then I have the Telebyte 500 series software, and I have a note here, notes on how to put the device into test mode 2, where we'll test the transmit output voltage level droop. So I'm going to write using PHY write and PHY read commands to the Analog Devices PHY, the MDIO registers I'm going to set up in a test mode 2 signal. You have to disable auto negotiation, and we enable a force mode. Then we write 4000 to this 0108F8 register to put it into test mode 2. And there we will get 10 plus 1 signals followed by 10 minus 1 symbols continuously. And that's the test signal that we'll use to measure our output voltage droop. All right, so then that's using the Termite software. We'll go to the Telebyte 500 series software and we'll open up the spectrum analyzer view. And this is a frequency domain view, and this looks like our test mode 2 signal here. We're actually looking out over 25 megahertz here. We can go out to 250 megahertz here, but we're just zoomed in on 25 megahertz. So this is the 10 ones followed by the 10 minus ones in the frequency domain. So then we can exit the spectrum analyzer and go to our noise signal capture software, the Telebyte 500 series software. And I have a test mode 2 with a 1 volt peak to peak .tfn file here. This is a Telebyte file. And we're going to start a capture 500 million samples a second. We're going to capture this signal for 2 seconds. And we're on channel 1. For test mode 2 and measuring transmitter output voltage droop, we use DC coupling, and we have 100 ohm load impedance for the phi, and then we have 2.5 volt digitizer range with a 0 dB setting. So I'm going to hit start here and capture the signal. And then we can hit the analysis window here, and we'll analyze the signal between the 2 red cursors here. So what I can see here in the time domain view on the left is the peak to peak value, and I see about a positive 0.5, a little over that, and a minus 0.5. And then I see the frequency domain view here in the middle window, and then the amplitude probability density function as statistics on the signal. So what I'll do is I'll zoom in by drawing a rectangular window around the signal to make sure that this looks like a test mode 2 signal. So I'm seeing 10 positive ones followed by 10 negative ones. And what the output droop test is doing is it's taking a 0 crossing here, and 133 nanoseconds later, it's looking at the voltage here, and then 800 nanoseconds from that crossing, it's looking at another voltage value. And we want this voltage to be less than 25%. There's the IEEE 802.3 DD standard that is increasing this to 25%. The original 802.3 CG spec that was ratified in 2019 is 10% droop, but I believe they're doing a lower cost modification on the 10BASE-T1L devices to lower the cost of the inductors on the device. So we've captured this signal, and basically what it's going to do is from 0 crossing, it's going to look at this value, and then 800 nanoseconds after the 0, look at this value and make sure that it's less than 10% or 25%. I'm going to run a test report here, and you can see we support the IEEE 802.3 CG and also the Ethernet Advanced Physical Layer. And I have an analog devices evaluation board here. It's the ADIN 1110 EDC eval board. And I'm in a 1 volt mode, and I'm in test mode 2. So we're going to capture the test mode 2 signal, and then we're going to generate the report. We could also include the test mode 1 signal that we captured. Now test mode 2 then will bring up a report, the 10BASE-T1L test report, and today's date. If we scroll through this, we'll see the table of contents. This is the test information, the software version, and the standard we're using as the pass and fail criteria, the 802.3 CG-2019, our digitizer and serial numbers, and our manufacturer and time date. So the transmitter output voltage is in test mode 1. The output droop is what we're using in test mode 2 here. And you see the 1 volt peak to peak currently has a 10% limit in the 802.3 CG standard. We measured 4.1% on the positive droop, and the negative droop is 4.4%. So that's a passing result. And you can see that that's taking the time 133 nanoseconds after the 0 crossing, and then 800 nanoseconds after the 0 crossing, and looking at what the difference is between those. And then the same here when you cross 0, 133 and 800, and looking at the value here. So that is a passing value. And then you can see the other results in the report from test mode 1.
Thank you for watching this demonstration today. Here are other videos that you'll find in this series.
We would be happy to provide you with more information. Please go to telebyte-SPE.com to learn more, or you can send an email using sales@telebyte-SPE.com.